So in this video, we're going to look at this equation here with a summation on both sides and a function with slightly different inputs, where the function is an arithmetic function. Now, if you check the link below, there'll be some links to videos which will explain arithmetic functions in a bit more detail. So some are multiplicative and some are additive, and some are completely multiplicative and some are completely additive. So, but in this video, we're going to have a look at this property here. So we've got this here, dn, that's divisors of n. So that's what that stands for. So d is divisors and n is the number. So that's what that stands for. Now, for example, if you take the number 12, so let n equal 12, our set of divisors will be 1, 2, 3, 4, 6, and 12. Okay, so here we calculate the function at those divisors, and it should equal, when all those functions are added up, to the function of n divided by those divisors. So in this case, we're going to use is 12. So first of all, let's look at this one and see what that actually means. So divisors of n, and we've got f of d. So what that means is the addition of all the functions of d. So the divisors in this case, let's use 12. So if I just use 12 as our example, so I've got f of 1, f of 2, f of 3, and so on. So I'll just write all these out. F of 3, f of 4, f of 6, and f of 12. Okay, so that's that one written out. So hopefully what we do, when we do this one, we get something very similar, in fact the exact same. So let's have a look at this one. So this time we want divisors of 12, but this time we want f of 12 divided by d. So what we do is take 12 and divide it by each one of the divisors. So if I just go down the list, I've got 12 over 1, 12 over 2, 12 over 3, 12 over 4, 12 over 6, and 12 over 12. And they all become 12, 6, 4, 3, 2, and 1. So if I write all those out, I will get exactly the same functions. So let's just write that out. F3, F4, F6, and F of 12. Now, will that work for every number? Well, it's going to work for every number because every number is divided by its divisors. And then if you take the inverse of each one of those, so 12 will give you 1, then 12 to 2, 12 to 3, that's going to give you the reverse order of the divisors in the first place. So that works for every number. So if I just pick the number 4, its divisors are 1, 2, and 4. Then 4 divided by each of those. If I just do that, then I get 4, 2, and 1. Same if I choose 10. So if I choose 10, my divisors are 1, 2, and 5, and 10. And again, divide it by 10. So just keep going along the line like that. I get 10, 5, 2, and 1, and so on. And that even works for prime numbers. So if I pick the number 29, my divisors of that are 1 and 29. Take 29 and divide it by all of these. And again, I get back to where I started from, but in reverse order. Let's put 29 there. And that proves that this will always hold for an arithmetic function. Okay.